This video is the first of a series for OpenIntro Statistics. I like to start all of my videos with a summary slide that covers all the main points of my video, and I will spend about 5 minutes at the beginning of each video going over this overview slide before going over each of the topics in more detail and with more examples. This video covers the first topic of Chapter 1, which introduces us to data, and the topic we will be covering are case studies. Case studies allow us to study a question. We formulate the question in terms of a hypothesis, so a hypothesis is simply a statement of the question we are studying. Your book has emphasized case studies in medical situations. For this reason, we have treatment and control groups. So patients are assigned to one of two groups, the treatment group, where patients receive the treatment being studied, and the control group does not receive the treatment being studied. And the control group provides a reference which we can measure and compare the medical impact of the treatment being studied. As much as possible, we want the control group to be like the treatment group in every way possible, with the exception of the treatment. In this way, any difference in response between the two groups is likely to be due to the effect of the treatment. An important idea in assigning patients into treatment and control groups is to randomize that assignment. So we want to make sure the treatment group is like the control group. So we have investigators put subjects into treatment or control groups at random. This will eliminate bias and problems of patients self-assigning them into treatment or control groups. An example of this, if there is a treatment that might have some complications, doctors might tend to put the healthier people who can withstand complications into a treatment group and then let the control groups be the ones who maybe won't be able to withstand a difficult treatment. And in this way, we've biased our sample. Similarly, if we have patients self-assign themselves into treatment or control groups, or people who want a test treatment versus people who do not want an experimental treatment, we have this difference between the two groups of people who are willing to risk an experimental treatment versus people who are not. So the randomized assignment will eliminate these two problems here. The next idea that's important is the idea of a placebo. And a placebo is a natural substance that resembles the treatment to counter the strength of an idea of treatment. That is the placebo effect. Sometimes when people receive something they believe will help them, then they might be more in the mind frame, and their mind might have a lot of influence over their ability to recover. So an example is in Harry Potter, when Harry gives Ron that Felix, the good luck potion, which actually is a placebo, but Ron believes he's been given a potion to give him good luck, and he starts to win at, Quidditch. So what we will see is that the control group, the patients that do not receive treatment, will often be given a placebo. And this makes the patients in the treatment and control group blind to their status. They don't know whether they're receiving the real treatment or the placebo. Once we have all of our data from all of our test subjects, we often don't look at individuals and their data, but we look at summary statistics. Those are numbers that summarize a large amount of data. Once we have our summary statistics, we want to compare summary statistics between the treatment and control group. And once we have that comparison, we have to be careful of statistically significant differences and also other factors. So first, if there's a difference in results between the treatment and control groups, an important question is, does the data show a real difference between the groups? That is the result statistically significant, or is it a variation that can be explained by chance or random factors? So an explanation of this is, for example, while we're randomly putting people into treatment and control groups, the random process involves chance. And it just might happen every now and then you accidentally put all the people who were going to get well anyway into the treatment group. Or it might be the other way. Just by random chance, when you're randomly assigning patients to the group, you might put all the people who are going to get well into the control group. And that's just dumb bad luck. But that does happen because when you do these random processes or something with chance, sometimes you're going to get a bad sample. So that's what this is here, or one example of this. We will look at statistical significance even more later in this book. We should also look at other factors. That is, are there other factors in the study that could affect the result? One example is this sample representative of the population you want to study? So if you want to make a general statement about the efficacy of some treatment on all people, then you want to study all people. But it might be the case, for whatever reason, you're only going to study adults. Maybe you can't get permission to study on children or something, in which case your study doesn't exactly represent the population of all people, but you have a sample of adults, and you want to be careful when you generalize then to all people. Another example is the treatment being studied representative of the type of treatment you are studying. So an example of this, I might try to make the claim that anyone who gets tutoring will get better grades in math. And the problem with this is that I might provide tutoring to a group of students, and I might find that they don't get better grades at math. But it might not be that tutoring is a bad thing or doesn't help people get better grades. It just might be my tutoring. So it might be my failure as a tutor. It isn't necessarily that tutoring is bad. In other words, the tutoring in my study, that's my tutoring, my personal me tutoring someone, might not be representative of tutoring in general. It might be that there's some other type of tutoring that's even better, that will promote better grades. Another question you might ask, how is effectiveness of the treatment measured? So in other words, if I wanted to measure the effectiveness of my tutoring, we might take an SAT exam or some other exam, but it might be the exam wasn't a good measure of how well I learned the subject. In which case, we might want some other tool or other exam to measure the effectiveness of my mathematical learning. Another example, which we've already discussed when we talked about randomized treatment, is if treatment and control groups are not randomly assigned, how could they differ? And we talked about how, like for a surgery, the people who might self-assign into a kind of experimental surgery might be the people who are healthier to begin with. So those are our 6 main points of our case studies. I've summarized them here: define hypothesis, treatment and control groups, randomized assignments, placebo, summary statistics, and statistical significance and other factors. I'm going to move this summary up here so that you can refer to them as we do our 3 case studies for this chapter. So here I have my 6 different points. And our first case study will be using stents to prevent strokes. We consider an experiment that studies the effectiveness of stents in treating patients at risk of stroke. Stents are devices put inside blood vessels that assist in patient recovery after cardiac events and reduce the risk of additional heart attacks or deaths. Many doctors had hoped there would be similar benefits for patients at risk of strokes. The question we are trying to ask is, do stents reduce the risk of strokes? So I define my hypothesis, which is a statement about my question, and my hypothesis then will be the use of stents reduces the risk of strokes. Next, we define our treatment and control groups. Ideally, we will randomize the assignment of patients into treatment and control groups. So what we will have is volunteer patients are randomly assigned to one of two groups. The treatment group, which are the patients that receive a stent and medical management. Then we have the control group, which receive the same medical management as the treatment group, but they do not receive stents. Ideally, we would use placebos in our control group, but in this case, because inserting a stent is a surgical procedure, generally we're not going to give this control group surgeries that don't do anything. So in this study, there are no placebos for the control group. We have a little more explanation from your book about this study. Researchers randomly assigned 224 patients to the treatment group and 212 to the control group. Again, we've already noted that this is a random assignment. In the study, the control group provides a reference point against which we can measure or compare the medical impact of the steps in the treatment group, that is, the stents. As much as possible, we want the control group to look like the treatment group in every possible way, with the exception of the treatment. In this slide, I got rid of the extra description of our study because I wanted to make more room for our summary statistics and results. But I kept the hypothesis, the description of the treatment and control groups, as well as the randomized assignment to treatment and control groups. Here we have patient outcomes summarized in a table. We check on the patients 0 to 30 days after the stents were implanted, and then we check 0 to 35 days. We ask the treatment group if they've had a stroke or no event after 0 to 30 days, and we ask the same question of the treatment group if they've had a stroke or no event, 0 to 365 days, a year later. We also ask the same question of the control group. After 1 month, if there's a stroke or no stroke, and after a year, if they've had a stroke or no stroke. And these are the totals here. So 0 to 30 days, we've had 46 people total with a stroke, 33 from the treatment group, 13 from the control. After 1 month, we've had 405 people with no strokes, no event, 191 from the treatment group, 214 from the control group. After 1 year, we have 73 total people with strokes, 45 from the treatment group, 28 from the control, and after a year, 378 total people with no stroke events, 179 from the treatment group, and 199 from the control group. So this is our summary table. So let's look at some summary statistics. So we want to know the proportion or the percentage of patients who had a stroke in the treatment group. So after 1 year, we have 45 people in the treatment group with a stroke. And that's out of a total of 45 plus 179 people in the treatment group. So that's 45 over 224 people, which is equal to 20%. So 20% of patients in the treatment group had a stroke within the first year. Let's compare that to the summary statistic for patients who had a stroke in the control group. So after a year, we've had 28 people in the control group with a stroke, and that's out of 28 plus 199 total people in the control group. So that's 28 over 227. So the percentage is 12%. And this is sort of surprising because we were hoping that the stents would be beneficial towards preventing stroke, right? Our hypothesis is the use of stents reduces the risk of stroke. But here it looks like that the treatment group had a higher percentage chance or rate of having a stroke. So this is contrary to what doctors expected, and it actually looks like the stents may have harmed the patients. However, we need to look at our statistical significance and other factors. So if there's a difference in results between the treatment and control groups, an important question is there a real difference between the groups? Is the result statistically significant, or can it be explained by chance or random factors? So here, we do have a difference between the treatment, here's the treatment, and the control group. It looks like the treatment group had a 20% chance of stroke, whereas the control group only had a 12%. So the treatment group seems to be 8% more likely to have a stroke. Is this something that's a real difference, or is this something that can happen by random because we're taking a sample of the general population? Maybe some of our samples, because when you sample, you do that randomly or statistically. When you take a sample, sometimes your sample will not represent the whole population. It just might be a bad sample. How do we determine if this variation, this 8% difference, is a real difference versus something that can be explained by chance? Well, that's something we'll learn later how to answer. But we can look at other factors. So is the sample representative of the population you want to study? Is the treatment being studied representative of the type of treatment you're studying? How is effectiveness of the treatment measured? And if treatment control groups are not randomly assigned, how are they different? So one of the first questions, are the participants representative of all stroke patients? It doesn't seem like there's a lot, except for the fact that over here, we talked about these are volunteer patients. And so the thing about volunteer patients is they may or may not be representative of people, general people who have strokes, mostly because it might be the case that people who are more likely to refuse a surgical procedure, maybe it's because they're not healthy enough. So our volunteer patients might represent a proportion of stroke candidates that are actually healthier than the general population of stroke patients. So maybe there's a difference between those who would volunteer for a study versus patients who would not volunteer. However, the fact that they are volunteers doesn't seem like it's going to impact this type of numbers. It's just a warning. But what might impact these type of numbers? Well, there are different kinds of stents. So this goes back to whether or not the treatment is representative of all the types of treatments you should consider. And in this case, a particular brand or company-made stent or style of stent was used. So it may be that a different stent would show different results, where that patients who had treatment would then get a lower rate of strokes than people who hadn't. So this is one limitation of this study that's probably more applicable. So I put a little asterisk next to it. And then it's always possible that there's statistical error due to chance. As we had discussed before, when you're randomly assigning people, you might just have randomly assigned all the people who were not going to have strokes anyway into the control group, just by dumb luck. Our second case study has the question, is acupuncture an effective treatment for migraines? So a migraine is a particularly painful type of headache. Patients sometimes wish to treat with acupuncture. So our hypothesis will be acupuncture is an effective treatment for migraines. After we define our hypothesis, we need our treatment and control groups. In this study, our treatment and control groups comes from a group of women diagnosed with migraine headaches, and they were randomly assigned to the treatment and control groups. The treatment group received acupuncture specifically designed to treat migraines, and the control group received placebo acupuncture. That is, a needle was inserted in non-acupoint locations. So we defined our treatment and control groups. We have a randomized assignment, because this was stated here, and we have a placebo. This is a table summarizing our results. We have our treatment and control groups here. We asked if they were pain-free after 24 hours of treatment. In the treatment group, 10 people said yes and 33 people said no. In the control group, 2 people said yes and 44 people said no. So the total number of people who said yes is our 10 plus 2 is 12. And the total number of people who were not pain-free after 24 hours was our 33 plus 44 is 77 people. So how many people in total do we have in the control group? We have 43 people, or the 10 plus 33, so I should write that down. 43 people total here. And then the total number of people in the control group is 2 plus 44, which is 46. From our data here, we want to look at summary statistics. What percentage of patients in the treatment group were pain-free 24 hours after receiving treatment? Well, the number of people who were pain-free in the treatment group was 10 out of a total of 43 people. So that's going to be 10, that's the number of people that were pain-free, divided by the total number of people in the treatment group, that's 10 plus 33, which is 43. So we have 10 divided by 43 is 0.232, so that's approximately 23%. Next, we have what percentage were pain-free in the control group. So we have 2 people out of the 46 people in the control group, which means we have 2 divided by 2 plus 44, or 2 divided by 46, which is 0.043. So we are approximately, moving the decimal over 2, approximately 4%. In which group did a higher percentage of the patients become pain-free 24 hours after receiving treatment? So that looks like it's the treatment group, because 23% were pain-free as opposed to only 4% in the control group. Now that we have our summary statistics, we need to consider statistical significance and other factors. As I had mentioned, we'll look more at statistical significance, but it's something we should keep in mind, and we should also look at other factors. So our findings might suggest acupuncture is an effective treatment for migraines for all people. And this is also one other key statement here. However, this is not the only possible conclusion that can be drawn based on your findings so far. What is one other possible explanation for the observed difference? So the first thing I noted is this is a study of only females, right? We talked about here a study, a group of women. However, later we were asking, how does this relate? This is about treating all people. So this is a study of only females, but the fact that they're all females probably won't explain the difference here between the percentage of people being pain-free after 24 hours. So the only thing that I could really come up with is perhaps the difference is a factor of chance. In other words, it was just bad luck. In other words, when we randomly assigned women to treatment and control, maybe we just randomly assigned the people who are going to get better into the treatment group. So just kind of a chance, bad random assignment of treatment and control groups. To review what we have covered in this video, we looked at case studies to produce data to answer questions that we are studying. The 2 case studies that we looked at was whether or not stents would help prevent strokes, and the second case study is whether or not acupuncture would help prevent migraines. And the steps we took were first to define a hypothesis. So a hypothesis is a statement of the question we are studying. So for example, if the question is, does acupuncture help migraines? The hypothesis would be acupuncture is an effective treatment for migraines. Once we have our hypothesis, we defined our treatment and control groups, and patients were assigned to either the treatment group, which received the treatment being studied, or the control group, which did not receive the treatment being studied. Because we use the control group as a reference point against which we can compare the medical impact on the treatment group, we want the control group to be as identical as possible to the treatment group in every way except for treatment. In this way, if there's any difference in response between the 2 groups to a treatment, then it is likely due to the effect of the treatment. And part of making our treatment and control group look as much alike as possible is that we try to randomize assignment of people into treatment and control groups. To make sure the treatment group is like the control group, investigators put subjects into treatment or control groups at random. This eliminates bias and problems of self-assignment. Next, we talked about placebo, which is a neutral substance. In other words, it doesn't really do anything, that resembles treatment to counter the strength of the idea of a treatment. So in other words, often people say the mind is a very powerful thing. We don't want the placebo effect of people thinking they've had treatment is what helps them get better. This makes patients blind to their status as far as being part of the treatment or control group, because the control group receives the placebo, which looks exactly the same to them as the treatment. Once we've done our study, we can have summary statistics, which are numbers that summarize a large amount of data. And from our summary statistics, we are tempted to draw a conclusion. But our conclusions we need to look at and see if they're statistically significant and if there are other factors that might explain the difference in effectiveness in the treatment or control group. That is, if there's a difference in results between the treatment and control groups, an important question is, does the data show a real difference? Or is the result statistically significant? Or is it variation that can be explained by chance or random factors? And by random factors, one possibility is that when we randomized our treatment and control groups, because it's done at random, there is some chance, and it is possible that all the people who are going to get well anyway are put into the treatment group, or all the people that were going to get well anyway are put into the control group. It just might be a bad randomization, not because anyone did anything wrong, but randomization has some element of chance. So sometimes that's going to affect our study. Also, there are other factors we should consider because other factors in the study could affect our result. Examples could be, is the sample representative of the population you want to study? So for example, when we looked at migraine and acupuncture, our study that we looked at was done on a group of women, but we really do want to talk about migraines in all people. And so it's possible that women have a different chemistry. Well, it's absolutely a fact that women will have different chemistry than men, so the study might be different for men versus women. So maybe a study on men might be a good pairing or partner for this study. Another question is, how is effectiveness of treatment measured? Is it something that patients themselves self-report, or is there a totally objective test like a blood test that we can use? Another question might be, if treatment and control groups are not randomly assigned, how could they differ? And the classic example of that is if the treatment is a surgical procedure, because often people who are very unhealthy are not able to undergo additional or unnecessary surgeries, so they're much less likely to be put into treatment group, which means under those conditions, the control group is already a group of people who are healthier to begin with, so that might skew things. So these are the 6 main ideas in this chapter, and that's it for this video. Thank you for watching.